Hello everyone, I'm Subui from Alamkul, and in the last lecture we have seen in the polynomial chapter that what is the remainder theorem. We have solved numericals also on based on remainder theorem. Okay, so today, as I told you in my last lecture, we were going to learn about factorization of the polynomial. Okay, how you're going to factorize a polynomial. Okay, so we need to learn about factor theorem. What does the factor theorem says? Okay, so let's get started. So this is your factor theorem. Okay, 10 minutes. Okay. So factor theorem. What does the factor theorem says? Let px be a polynomial. Okay, we are having a polynomial, say px, okay, whose degree is n. Okay, and the polynomial should be greater. The degree of the polynomial should be greater than or equal to 1. Okay, it should not be a constant. Okay, so we are having a polynomial px whose degree is n, which is equal to or greater than 1, and we are having any real number a. Okay, now here are the two conditions. What you can see because with the factor theorem. First, that PA is equal to 0. Okay, PA is equal to 0. Then if PA is equal to 0, then x minus a is a factor of px. Okay, now what does the statement say? If you have already seen the remainder theorem. PA is equal to 0 means our remainder is 0. So if the remainder is 0, that means the number from which we are dividing, that is x minus a, that is a factor of px. Okay, and if x minus a is a factor of px, okay, it is fully dividing that given polynomial, then the remainder will be 0. Then PA is equal to 0. Okay, now let's quickly see the proof of this, and then we will come on some of the examples. Okay, there are two types of question that you will find in this related to factor theorem. Okay, now first we are going to choose the first one, that is when PA is equal to 0. Given what is given in this one, PA is equal to 0. Okay, now from the long division method, we already know when we are dividing any polynomial px. Okay, now here the polynomial is px and we are dividing with x minus a. Okay, so px is equal to x minus a, then it is multiplied by what? Qx. Okay, plus rx. Okay, this was our from the long division method. Okay, now here the remainder is not rx, here the remainder is pa. Okay, from the remainder theorem. Okay, we have already studied the remainder theorem, and from remainder theorem we know that the remainder will be, if we are dividing with this particular polynomial, then the remainder will be pa. Okay, so according to that, px, okay, is equal to x minus a, okay, multiplied by qx, okay, plus pa. Okay, now since it is already given that pa is equal to 0. Okay, so that implies that px is equal to x minus a qx. Okay, because pa is equal to 0. So that means that x minus a is a factor of px. Okay, you can clearly see there is no any term. So x minus a is a factor of px. Okay, now the second one is what? The second one, what does it say is that if x minus a is a factor of px, then pa is equal to 0. Now we have seen where it is given that x minus a be a factor of px. Okay, now if this is a factor of px, that means that px is completely divided by x minus a. Okay, and we are taking gx as a question. Okay, when we divide it. So according to the division formula, okay, what we get? Yes. Now, if we are putting x is equal to a, because since this is a factor, so x is equal to a, by putting x equal to a, we'll get 0. Okay, so PA is equal to a minus a gx. Okay, so PA is equal to 0. Okay, that means x minus a is a factor of PA. That means PA will be equal to 0. Okay, so we have proved this factor theorem. Okay, you can clearly see here with the proper statement format. Okay, in your examination, you are going to prove like this. Okay, factor theorem is not going to come. Very rare it is. Okay, the question based on the factor theorem are going to come in your examinations. Okay, now what we have seen in the factor theorem, according to it, we have used that if x plus a is a factor of px, that means what? If x plus a, so what we are going to do, x plus a is equal to, we are going to put 0, so x is equal to minus a. So this is x minus a, then minus a is equal to 0. Okay, p minus a is equal to 0, that it says. Okay, similarly, if ax minus b is a factor of px, that means b by a is equal to 0. Okay, so this is about factor theorem. Now in this factor theorem, related to factor theorem, you will get two types of questions. Okay, what are the two types of questions here? That sometime what you will get that in a given polynomial, missing term will be there. Okay, any unknown term will be there, and one of its factor will be given. Okay, so you need to find out that unknown term. Okay, it is clearly I have already mentioned for you see, polynomial having unknown value and one of its factors are given to us, and we have to just find the value of that unknown term. Okay, both the type of question we are going to see today. Okay, now, and another type of question that you will be having, that you have to check that a given polynomial is a factor of the polynomial or not. Okay, one of the polynomial. Okay, so let's see. On first type one. Type one question is here. Let me copy this type one question. So as you can see, what is our question? That is, if is missing here. If x minus a is a factor of 4x square minus mx minus na, then we have to prove that a is equal to m plus. That means, see, a here is a missing term. We need to find out. Okay, a constant term is not there. It's in form of, the constant is given in an unknown form. Okay, we need to find out this unknown value, the constant's unknown value. Okay, and but it is already mentioned that x minus a is one of the factor of the given polynomial. Okay, so here px is given as 4x square minus mx minus na. Okay, now if x minus a is a factor of px, then pa is equal to 0. Okay, according to this factor theorem. Okay, therefore 4a square minus ma minus na, okay, is equal to 0. Now you can see in all the term a is there. I'm taking a as common. 4a minus m minus n is equal to 0. If a will go on that side, it will be 0. 4a minus m minus n is equal to 0. Okay, so 4a is equal to m plus n and a is equal to m plus n by 4. Okay, because we need to prove that a is equal to m plus n by 4. Okay, so you can see we have got a is equal to m plus n by 4. Okay, this is one type of question. Okay, it may not be there to prove only. Okay, it may just given they find out the value of a. Okay, if this is a factor of this polynomial. Okay, now second type of question that you will see, that you need to prove that a given polynomial is a factor. Okay, now using factor theorem, show that x plus 1 is a factor of what? X to the power 19 plus 1. Okay, so here qx is equal to x plus 1. Okay, and px is equal to x to the power 19 plus 1. Okay, now we need to prove this. So what we are going to do, we are going to put x plus 1 is equal to 0, which implies that x is equal to minus 1. Okay, so we are going to put this in minus 1 to the power 19 plus 1. Okay, so since power is 19, so we'll get the power is odd, so the sign will be negative only. Okay, minus 1 plus 1. Okay, so it will be 0. So you can see, as we are getting p minus 1 is equal to 0 from the factor theorem, what does it say here? If p is equal to 0, then x minus a is a factor of px. Okay, same we have got, since p minus 1 is equal to 0, therefore x plus 1 will be the factor of x to the power 19 plus 1. Okay, understood? So this was all about your factor theorem and the type of question that you will get in the factor theorem. Okay, there are two types of question, two category of question you will be getting in your factor theorem. What the category of question I have discussed here. Okay, based on this only. Okay, you can see here in the factor theorem also you have 2 points. Okay, if pa is equal to 0, then x minus a is a factor of px. So one you will be getting on this part, okay, of questions, and one on if x minus a is a factor of px, then pa will be equal to 0. Okay, so just go through this factor theorem. Okay, and in our next lecture we'll be discussing how to factorize a quadratic polynomial and how to factorize a cubic polynomial. Okay, we'll be using factor theorem also and splitting the middle term. Okay, so that we will see in the next lecture. Till then, bye bye, and don't forget to like and subscribe. Okay, bye.